So we are going to discuss another problem on stochastic process. So the problem is based on stationary process. So the problem goes like this. A random process x of t is defined by x of t equal to a cos omega t plus phi, where omega is a constant. So omega is a constant, a is a random variable, and a is uniformly distributed in the interval 0, 1, and phi is also a random variable which is independent of a. So phi is independent of a and which is also uniformly distributed in 0 to pi. So we have to determine whether the process x of t is weakly stationary or not. Weakly stationary, that means Whiteson stationary or covariance stationary. Okay, so let's see how we can solve this problem. So a random process is known as weakly stationary or covariance stationary when its mean is a constant, that is expectation of x of t equal to a constant, and the second condition is that its autocorrelation function rx t1 t2 is a function of time difference. Okay, these two are the conditions for a process to be weakly stationary. So let's see the given process is weakly stationary or not. So for that, first of all, we have to find expectation of x of t. So let's see what is expectation of x of t. Expectation of x of t equal to what is x of t? A cos omega t plus phi. So expectation of a cos omega t plus phi. And in the problem it is given that a is a random variable and phi is also a random variable and they are independent. Since the random variables are independent, we are having the conditions that if a random variable a and b are independent, then expectation of ab can be written as expectation of a into expectation of b. So since a and phi are independent, we can write this as expectation of a into expectation of cos omega t plus phi. Okay, now let us see what is expectation of a and expectation of cos omega t. So we are given that a is a random variable and it is uniformly distributed in the interval 0, 1. Then what will be f of a? F of a will be uniform distribution. It is following uniform distribution. So this will be 1 by b minus a. So a is equal to 0 and b equal to 1. So 1 by b minus a means 1 by 1 minus 0, which is 1, over the limit 0 and 1. And what is expectation of a then? We know that expectation of uniform distribution is b plus a by 2. So b plus a by 2 means 1 plus 0 by 2, that is 1 by 2. So expectation of a is 1 by 2. Now we have to find expectation of cos omega t plus phi. So let us see what is expectation of cos omega t plus phi. So which is equal to integral. What is the distribution of phi? Distribution of phi is given as phi is uniformly distributed in 0 to pi. So distribution of phi is uniform distribution in between 0 to pi. So what is f of pi then? F of phi. F of phi will be 1 by 2 pi since it is uniformly distributed over 0 and 2 pi. So which is 1 by 2 pi. So the range of the integral will be 0 to 2 pi. So let us substitute that integral 0 to 2 pi, and expectation of a function is what? That function into our probability density function. So here it is phi. So this is f of phi d phi. Okay. Now which is equal to integral 0 to 2 pi cos omega t plus phi into f of phi is 1 by 2 pi. So let us substitute that 1 by 2 pi d phi. Now let us integrate cos omega t plus phi. Okay. So let us integrate this with respect to phi. So the function is integral 0 to 2 pi cos omega t plus phi into f of phi is 1 by 2 pi d phi. Now let us take 1 by 2 pi outside. So 1 by 2 pi, and what is integral cos omega t plus phi? What is the integral value of cos omega t plus phi, which is sin omega t phi, right? Integral of cos is sin. So this will become 1 by 2 pi sin omega t plus phi over the limit 0 to 2 pi. Now let us substitute this. So 1 by 2 pi sin omega t plus 2 pi minus sin omega t plus 0, that is sin omega t. Now what is sin pi plus sin 2 pi plus x? Sin 2 pi plus x is sin x. Okay, so this will become what? Sin 2 pi plus x is sin x. So this will become 1 by 2 pi sin omega t minus sin omega t. So this is 0. So expectation of cos omega t plus phi is 0. So when we substitute that in expectation of x of t, what will happen? Expectation of x of t, which is equal to expectation of a, we obtained as, what was expectation of a? We got expectation of a is 1 by 2, and expectation of cos omega t plus phi is 0. So expectation of x of t will be 0. So expectation of x of t equal to 0. So which is a constant. So which is a constant term. So the first condition is satisfied. That is our cos omega t equal to a constant. Sorry, expectation of x of t equal to a constant. Now we have to prove that our autocorrelation function is a function of time difference. Autocorrelation function is a function of time difference. So what is autocorrelation function? Rx of t1, t2, which is equal to expectation of x of t1 into x of t2. So which is equal to expectation of, what is x of t1? X of t1, x of t is a cos omega t plus phi. So this will be expectation of a cos omega t1 plus phi into a cos omega t2 plus phi. Right. Now a and phi are independent random variables. So a into a is a square. So this will become expectation of a square into expectation of cos omega t1 plus phi into cos omega t2 plus phi. Okay, fine. Now we have to find what is expectation of a square and what is this. So let us find what is expectation of a square first. So expectation of a square equal to integral. What is the distribution of a? A is distributed, uniformly distributed in the interval 0 to 1. So what is f of a? F of a will be 1 by 1 minus 0, which is equal to 1. So this is in the interval 0 and 1. Okay. So integral 0 to 1 expectation of a square. So expectation of a function, that function into its PDF. So which is equal to integral 0 to 1 a square into 1 dA. Now let us integrate this. So a square is a cube by 3 over the limit 0 to 1 and substitute this. So 1 by 3, what? A cube. Okay, we can substitute for 1. So 1 by 3 will be the answer. Okay, so expectation of a square is 1 by 3. Now we have to find this. So expectation of cos omega t1 plus 5 into cos omega t2 plus 5. What is cos A, cos B? Which is 1 by 2 cos A plus B. So this is A and this is B. So cos A plus B is omega t1 plus 5 plus B is omega t2 plus 5 plus cos A minus B. So omega t1 plus 5 minus omega t2 minus 5. So this 5 getting cancelled and we are having, we can take this 1 by 2 outside. 1 by 2 expectation of cos omega, we can take this omega outside. So t1 plus t2, t1 plus t2 and 5 plus 5 which is 2 5 plus here we are having omega t1 minus omega t2. So this will become cos omega t1 minus t2. Okay. Now we can find the expected value of this function. And you can see that in the second term there is only t1, t2 and omega. Here our random variable is phi and a. So this term does not contain the random variables a and phi. So this is a constant. So when we are taking expectation, this will become expectation of a constant. So this will be our value. So this will become what? 1 by 2. Expectation of this, since this is addition, we can write this term first. So expectation of this is this function itself, because this is independent of phi and a. They are the random variable. So cos omega t1 minus t2 plus 1 by 2 expectation of cos omega t1 plus t2 plus 2 phi. Now let us see the expected value of this. So expected value of cos omega t1 plus t2 plus 2 phi, which is equal to, so this is a function of phi. So phi is uniformly distributed in 0 to pi and our f of phi is 1 by 2 pi. So this function into over the limit 0 to 2 pi cos omega t1 plus t2 plus 2 phi into f of phi d phi. So which is equal to integral 0 to 2 pi cos omega t1 plus t2 plus 2 phi. F of phi is 1 by 2 pi d phi. Now we can take this 1 by 2 pi outside and this will become sine omega t1 plus t2 plus 2 phi. So here you are having 2 phi. So coefficient of phi is 2. So divided by 2. 0 to 2 pi. So when we apply this limit in the place of phi, what will happen? 1 by 2 pi sine omega t1 plus t2. Okay, this 2 can be taken outside also. Okay, t1 plus t2 plus this will become 4 pi minus sine omega t1 plus t2 and phi is 0. So what is this function? This function is again sine omega t1 plus t2, and here also we are having sine omega t1 plus t2. So this minus this will become 0. So this expectation is 0. So what is now Rx's of t1 t2? We have obtained Rx's of t1 t2 is expectation of a square. Expectation of a square is 1 by 3. Okay, so 1 by 3 into expectation of cos omega t1. Okay, here expectation of cos omega t1 plus phi, this term. Okay, this is obtained as what? This plus 0, right? Because the second term became 0. So this is the first term. So this into 1 by 2 cos omega t1 minus t2. That is 1 by 6 cos omega t1 minus t2. So which is a function of time difference. That is, this is 1 by 6 cos omega 2. So function of time difference. That means we have satisfied the two conditions. That is, expectation of a process is a constant, and also the autocorrelation function is a function of time difference. Hence, this process is WSS.